Hello everyone. We are starting a free open lecture on Discord. Our lectures are held weekly. If you are a viewer and want to ask your question and get an answer, join our lectures. You can find the link to Discord in our Telegram channel. There you can also find out the schedule for the lectures. Join us. So, let's get started. In the last session, we covered the main and important stages and steps in a machine learning project. And the central part of any such project, which is absolutely crucial for the success of the project, is a specific model, which we use in machine learning. And today we will start the part of our course where we will be looking at various different models in machine learning and artificial intelligence. And the first part will be dedicated to all kinds of various types of regression analysis. In particular, we will be looking at linear regression, multiple regression, logistic regression, and possibly, if time permits, some other types of regression. According to the plan, I will try to combine, that is, first give you a general idea and theory that underlies each such model. Then we will look at its practical application in more detail and review some additional materials dedicated to this topic. Well, since we started talking about regression, today I will tell you about one of the methods that forms the basis of regression analysis, and specifically linear regression. This is the least squares method. Well, let's get started. First and foremost, we will begin with an example of setting up a linear regression problem. Let's consider a scenario where we have a certain observation. We will refer to this observation as TFSP. In this context, the variable t represents time, while the variable v stands for a specific parameter. This parameter could be anything relevant to our observation. So we have time values of approximately 1, 2, and 3. Corresponding to these times are parameter values of 0, 2, and 3 respectively. We can plot these points on the plane. Here we will have t1, 2, 3. And here we will have v respectively. This is 0, that is the point with coordinates 1, 0. This is 2 and this is 3. So to clarify, v stands for the variables v and v respectively. The point with coordinates 1, 0 is a specific location in the coordinate system. This is 2, which is another point, and this is 3, yet another point in the system. So we have 3 key points to discuss. These are our detailed observations. Let's make sure to record these important points carefully, as they represent some significant observations we have made. Want to become an awesome programmer? Subscribe to our Telegram channel for more updates and tutorials, and we are currently solving a linear regression problem. What does linear regression mean? It essentially means we need to approximate these points with a line, because the regression is linear. In other words, our task is to find a line that comes as close as possible to intersecting these 3 specific points. This means we need to carefully analyze the positions of the points and determine the best possible line that minimizes the distance to each of them. Well, it's clear that if it's a line, it is defined by some equation y equals kx plus b. Where depending on the values of k and b, this line will change. That is, it can be like this. It can be like that or some other way. Our task is to find it and draw it as close as possible to these 3 points. What does it mean to be as close as possible to these 3 points? It means that we find the distance from each point to this line. Sum all these distances, and we want this sum to be as small as possible. But here we see quite obviously that it is impossible to draw a line through all 3 points so that it passes through all 3. That is, you can draw a line through any 2 points. For example, through these 2 the line passes, but it misses the third one. Similarly, you can draw a line through these 2 points, but it will definitely overlook the third one. Accordingly, the line will pass somewhere approximately in the middle, somewhere around here. In fact, and we need to accurately determine the values of these coefficients, k and b, in order to proceed. In terms of machine learning, as I mentioned in the last class, such coefficients are usually denoted by the Greek letter theta, meaning they would be something like theta 0, t1, but it is not fundamentally important how they are denoted. The important thing is that we need to somehow, in some way or another, in some manner, in some fashion, find these coefficients. Let's immediately note the distance as we will calculate it. The distance is the perpendiculars that we drop onto this line. They are actually perpendicular to the fx axis, which means that they are not perpendicular to the line itself. In fact, so these distances, let this first one be called 1 reel, the second one be referred to as 2 reels, and the third one be named 3 reels respectively. And it's not hard to guess, since our method is called the least squares method, we will be looking for the sum of the squares of these distances. That is 1 reel squared plus 2 reels squared plus 3 reels squared. So this is R because it comes from the English word residual, meaning remainder. These are the 3 residuals, and they should be minimized. More precisely, the sum of their squares should be minimized. This will ensure that the line passes as close as possible to all 3 points. Now, how do we do this numerically? What formulas can we use to achieve this? Well, look, if the line actually initially passed through this first point with the coordinate t1, v1, what does that mean? This means, let me actually write the line here. I will use the letters beta for the coefficients, so I will write it as beta 1x plus beta 0 equals y, like this. If the line passed through the first point, that is, through the point with coordinates 1, 0, it would indeed satisfy the equation beta 1 times 1 plus beta 0 equals 0. That is to say, it would satisfy the equation beta 1 times 1 plus beta 0 equals 0. So here we have 1, 0, as you can clearly see. We substitute 1 for x and 0 for y right here in this specific example. If the line passed through the second point, we would substitute the coordinates of the second point into the line equation and get a true equality. That is, we would get beta 1 multiplied by 2, add beta 0 equals 2. And if it passed through the third point, we would get the equation beta 1 times 3, add beta 0 equals 3. We end up with the following system of equations. We need to solve such a system. Find the coefficients beta 0. Solve to find these coefficients beta 0. So that all 3 equations have a solution. The problem is that from geometric considerations, as we can see here, such a solution does not exist. In other words, there are no such coefficients or numbers b0 and b1 that would make the line pass through all 3 points simultaneously, because they are arranged in this way. What should we do? Nevertheless, we somehow need to solve this, meaning we still need to find these 2 numbers somehow. It can't be done, but we still have to do it. We will proceed as follows. Since we know that we can draw a line here, if not through these points, then as close as possible to these points. And as close, what does that mean? It means that the line is at this distance from each point, 1 reel, 2 reels, 3 reels. That is, this system of equations has no solutions. That is, it is not consistent. What would a system that has a solution, that is, one that is consistent, look like? It would look as follows. I will now proceed to move beta to the left side of the equation. Beta 0, which is the intercept term, plus beta 1, which is the coefficient of the independent variable, multiplied by 1, plus 1 real, which represents the residual error, equals 0. 1 real is this. Residual 1. I will rewrite the second equation as b0 plus b1 times 2 plus 2 reals, which is residual 2 equals 2. I will rewrite the third equation as b0 plus b1 times 3 plus 3 reals, which is residual 3 equals 3. This way we can clearly see how each residual term fits into the equations. And in this particular form, we can already begin to search for a potential solution to this given system. That is, once again, we are looking for b0 and b1 coefficients. Since the exact position of the line changes slightly depending on these specific coefficients, accordingly, if the coefficients also change, what task are we pursuing? We want to find these coefficients, specifically beta 0 and beta 1, such that this sum of squares is minimized. This means we are looking for the values of beta 0 and beta 1 that make the sum of the squared differences as small as possible. That is, we are solving this kind of optimization task. It is essentially necessary to find the specific values of the parameters beta 0 and beta 1 under the condition that these three residuals are minimized. So we actually moved from this task to this task. This is task 1 and this is task 2. Since we are now going to take these very long paths through the thorns of various vectors, matrices, and other mathematics, you must not lose this essence and remember that we are solving. This assignment 1 through assignment 2, that is, we are indeed looking for coefficients. Well, not coefficients, but solutions. That is the numbers beta 0 and beta 1 under the condition that the errors are minimized. And also keep this picture in your mind. To make the cause and effect relationship clear once again, I will emphasize this. This system has solutions, and the solutions will vary depending on the values of R1, R2, and R3. That is, these points are fixed. 1, 0, 2, 2, 3, 3. We cannot change them. Beta 0, beta 1 are the solution. We are looking for them. These three numbers remain. 1 real, 2 reals, 3 reals. These errors, we can and will change them. That is, we need to change them in such a way that their sum, the sum of squares, is minimized. With these values that we find, we will solve this system and subsequently obtain some values for beta 0 and beta 1. The solution to this system, and we will say that they are the best approximate solution for this system. For system 1, that is the logic. Want to become a cool programmer? Subscribe to our Telegram channel.